We actually did number 5 in the previous video, but just to recap, 27 times 3 is pretty small, so I would just do it and get 81, and the fourth root of 81 is 3. Okay. I wouldn't jump right away to rationalizing number 6. I will always try to reduce my fractions first because it might save me some work, and you get a perfect cube, so the answer is just going to be 5. Now, number 7, I don't look at 104 and think, boy, that's a special number. You know, something to this power gets you that. So the way I would handle that if I'm not using a calculator is I would break 104 down using a factor tree. So I know that 2 and 52 go into 104, and 52 is 2 and 26, and 26 is 2 and 13. So I could rewrite 104 as 2 to the third times 13 to the first. And if that's all under the cube root, that's the same thing as all of that being to the 1/3. So this is really the same thing as writing 104 to the 1/3. But if I write it this way, I can go ahead and distribute my exponent and find out that I actually get 2, and then I get 13 to the 1/3, which becomes the cubed root of 13. Unfortunately, number 8, the fraction doesn't reduce, so we're going to have to jump right into separating it. I'm going to think ahead though, and I'm going to change 4 into 2 squared because I know I'm going to have to rationalize. So it looks like I'm going to need 3 more 2's in order to have 5 of them. So up top, 3 times 2 cubed is going to be basically 8 times 3, which is 24. And on the bottom, I'm just going to be left with 2. Number 9, we've actually learned in the past, but just in case, it's not going to work to just multiply by root 2 top and bottom because you have a 6 minus root 2 in the denominator. So we have to use what's called the conjugate. So we're actually going to multiply the top and the bottom by the conjugate. So if we do that, we'll get 18 and 3 root 2. On the bottom, 6 times 6 is 36. If I go ahead and FOIL this out, what I'm going to find out is I'm going to get 36 minus 2, which is 34. And if you look here, 18 and 34 can reduce, but 3 and 34 cannot. So 18 and 34 can become 9 and 17, but 3 and 34 has to remain unchanged. So that would be my simplified answer. Now number 10 is a subtraction problem, so the rules are very, very picky. You really want to see it as basically saying 7 chickens minus 1 chicken is 6 chickens. So when you're adding, subtracting, as long as the radicand is the exact same and the index is the same, you can go ahead and just subtract or add those outside numbers and you leave the radicand alone. It's kind of the same idea for 11. So we have 4 groups of this term plus 8 groups of that same term. That's the same thing as saying we have 12 groups of 9 to the 2/3. So before we go ahead and say, okay, we're done, we want to make sure that we don't actually have an improper fraction hidden in this problem. So if I change 9 to 3 squared and take that to the 2/3, I actually get 3 to the 4/3. So 9 to the 2/3 actually does reduce. So we're going to want to do that. Since I'm breaking numbers down, I'll go ahead and break 12 down into 2 squared times 3 to the first. And so this is the problem that I have to work out. So I know 2 squared times 3 is going to be 12, but this is not okay. I need to break this into 3 to the 3/3 and 3 to the 1/3. So 3 to the 3/3 is just 3. 3 times 3 is 9. 9 times 4 is 36. So I'm going to have a 36 when I multiply these ones together. And it looks like I'm going to have a 3 to the 1/3 left over. So I'll have the cubed root of 3. Last but not least, we have an addition problem, but we have different radicands. Now 5 does not break down, but 40 does. So I can handle this 2 ways. I can change 40 into a factor tree. So I can make it 8 and 5 if I wanted. And I know 8 is 2 cubed. So I could change this into 2 cubed times 5 all to the 1/3. Distribute my exponent, go from there. So that's one way to do it. But because 40 is such a small number, If you just think, is there a cube that goes into 40? Well, yeah, 8. I know 40 is 8 times 5. So I could break 40 into this. The cubed root of 8 is just 2. So I have 2 cubed root 5 plus 1 cubed root 5, which is going to make 3 cubed root 5. So it doesn't matter if you go the exponent route or if you just break down your radical. If they're small numbers, I probably just break them down, but if you have bigger numbers, you probably would want to go the exponent route.